Are we recording? Are we recording? Yes, we are. Hey, everybody, welcome back for another virtual lesson with Mr. Perry. Hope everybody's doing well and safe and sound in their house. Okay, all right, so let's get started. We are on lesson 12.5. Let's go over the essential question. Oh, how can you make and interpret line plots with fractional data? All right, so first, line plots. Let's go over line plots. I wonder if there's anywhere on this page where it's going to give us the definition of a line plot. I wonder, can anybody tell me? I wonder. Yeah, it's right there where it has it highlighted talking about line plots. Anybody would like to volunteer to read that short little insert about line plots? Anybody? Riley, oh, wonderful. Thank you for volunteering, Riley. You can use a line plot to solve the problem. A line plot is a graph that shows the frequency of data along a number line. Okay, so let's talk about that. The frequency of data along a number line. So a number line, it's pretty simple. A number line is just a line that has numbers on it. So let's just say 1, 2, and 3. The frequency is how many number ones there are. So I'm just going to put it a random x. And a random x above the 1, a random x above the 2, and a random x above the 3. I might put a random x, another random x above the 2. So to just talk about this line plot that I just created out of thin air, okay, how many number ones do you see? Now each number one is represented by just an x. So how many number ones are there? There's only one number one. How many number twos are there? Remember, the x represents how many number twos or ones or threes there are. So how many number twos? There are two x's. So that means there are two twos. And how many threes? There are only 1 3. Okay, so that was just a little kind of quick line plot. Now the line plots that we're dealing with today, they are going to be going in order from least to greatest. Well, all of the line plots are going to be going in order from least to greatest. Okay, but also the line plots that we're going to be dealing with are going to be fractions. So let's review a fraction. So 1/4, the 1 is the numerator, the 4 is the denominator. Numerator goes on top, denominator's on the bottom. D down, denominator down. Okay, so we're going to make a line plot with the following data about Jen's button collections, the length of buttons in her collection. All right, so let's first organize the data. So I'm going to put a tally over in this box here in regards to each of these points. Okay, so looking at the data over here, the first one is 1/4. So I'm going to come over to 1/4 in my box and put an x. I'm going to cross out that 1/4 because I don't want to have to, it tells me I already used it. The next fraction is 3/4. So I'm going to put an x in the 3/4 tally. Cross it out the top. All right, next is a 1/4. I'm going to put another x in the 1/4 category. Cross it out up here. 4/4, put an x, cross it out, another 1/4, cross it out, and then 4/4. Put an x there in 4/4, and don't forget to cross out that last 4/4. Okay, so step 1, order the data from least to greatest in length and complete, greatest length and complete the tally table. Did it, check mark. Okay, step 2, label the fraction lengths on the number line below from the least value to the greatest. From the least value of the data to the greatest. All right, so let's think about this. Let's review. I'm going to draw a circle. Okay, it's broken up into fourths. Okay, 4/4 would be considered the whole pie. So imagine that's a pizza pie. 4/4, every single piece. No one has eaten yet. Okay, I got a little hungry. I decided to eat just one piece. So now how many pieces are left? 3/4. And another piece. How many's left? 2/4. Then I ate another piece. How many pieces are left? 1/4. Okay, so the greatest number that we had is when the entire piece of the entire pie nobody ate, and I didn't eat any of the pie yet. So 4/4 is the greatest. So coming down to my number line, I'm going to put 4/4 right there. The smallest is 1/4. That's the smallest number, or smallest amount of, smallest fraction. Okay, and after 1/4, we have 2/4. Goes in order from least to greatest. 2/4, then 3/4. Okay, so 1/4, 2/4, 3/4, 4/4. Now the next thing we have to do is to use our tallies over here and to put them in our line plot. So under 1/4, I'm going to put how many X's above the 1/4? What do you think, Dibble? Yeah, you're right. We're going to put 3 X's above the 1/4 because going back to our tallies, there are 3 X's and 1/4. Okay. How many X's am I going to put above 2/4? What do you think? Let's see. Who haven't I heard from in a while? Oh, Dakota. What do you think, Dakota? How many X's am I going to put above 2/4? None? Well, that surely you have to put something. Why am I going to put none? Why am I going to leave it blank? That's right, because from our little section over here, our table, there are no 2/4. She doesn't have any buttons that are that has a length of 2/4. So I'm just going to leave it blank. Okay, so the next one, 3/4. How many X's am I going to put above 3/4? Just 1. Thank you, everybody. And then the last section, how many X's am I going to put above 4/4? Kason? That's right, 2 X's. All right, so now I just created my first line plot. Let's see if there are any questions below my line plot here that I need to answer, because I can't see it from my screen. Oh, the question was, so how many buttons are longer than 1/4 inch? Okay, so let's talk about this. So we're seeing how many buttons are longer than 1/4. So how many buttons are there? How many buttons does Jen have that are only 3/4 inches? She only has 1. Okay, because there's only 1 X. So how many buttons does she have that are 4/4 inches? Count the number of X's. Yeah, 2. So how many total buttons does she have that's longer than 1/4? So count all your X's or add up 1 plus 2. And we know 1 plus 2, or if you counted the X's, it's going to be 3 buttons. So she has 3 buttons. She has 3 buttons that are longer than 1/4 inch. Okay. Now let's answer these couple questions here. Right. How many buttons are in Jen's collection? Let me quickly redo our table here. Okay. All right, so let's count the total number of buttons. So the answer to that question is, how many X's are there? Count the total number of X's. I'm missing 1. Yeah, I knew there was 3 X's above there. Okay, so how many X's are there in the total line plot? So there's 3 above the 1/4. There's 1 above the 3/4 and 2 above the 4/4. So if you tally it up, 3 plus 1 plus 2, is a total of 6 buttons. Okay, question number 2. What is the difference in length between the longest button and the shortest button? The difference in length between the longest button and the shortest button in Jen's collection. We know the longest button is 4/4. Okay, and then the shortest button is 1/4. And there's a key word in here that tells us the operation. The key word is difference. So let's think. Difference means to what? JC? Sorry, JC, I didn't hear you. Speak up. Speak up there, girl. Yes, difference means to subtract. So I'm going to subtract 4/4 minus 1/4. Since my denominators are the same, my denominator in my difference is going to be the same as well, 4. So the next thing I have to do is subtract 4 minus 1. 4 minus 1 is 3. So the difference is 3/4 inch. Don't forget label. 3/4 inch, not inches. 3/4 inch. Okay. All right. So far, so good. We're on a good roll here. Okay, let's go to the next page. Next page. On page 666 and on example number 2. All right, so let's go over example number 2. Volunteer to read number 2. Okay, Mr. Perry, go ahead and read number 2. Some of the students in Miss Lee's class walk to school. The data show the distances these students walk. What distance do most students walk? Okay, first, make a line plot to show the data. All right, step 1, order the data from least to greatest and complete the tally table. Ooh, not tally table. All right, let me read step 1 again without mumbling. Order the data from least to greatest distance and complete the tally table. All right, so let's look at my data over here. So my data is all right there. So let's think about this. My smallest fraction, I have 1/2, 1/4, 3/4. Okay, of those, my smallest fraction is 1/4. Okay, my next smallest fraction, so after 1/4, we have 1/2. And then last but not least, we have 3/4. If we would create equivalent fractions with common denominators, my common denominator will be 4 because 4 is a multiple of 2. So if I would create common denominators, it would be 1/4, 2/4, and 3/4. The 2/4 is the same as 1/2. So that's where I'm getting that 2/4. All right, so let's throw some tallies in there. So anytime I see a 1/4, I'm going to throw a tally. 1/2, throw a tally. Put an X there. Cross it out. Another 1/2, X. Cross it out. Next one's 1/4, X. Cross it out. 3/4, X. Cross it out. 1/4, put an X. Cross it out. 1/2, cross it out, and then 1/2, cross it out. Okay, so the next thing I need to do, label the fraction lengths on the number line below from the least value of the data to the greatest value. So my smallest one is 1/4, and I have 1/2, and then 3/4. So now I just need to transfer these X's to my line plot. So 1/4 is going to have 2 X's. 1/2 is going to have 4 X's. Oh, and 3/4 is going to have only 1 X. All right, so let's think. So most students walk. So that's the question. What distance do most students walk? So to answer this, let's take a look at our line plot and see the total number of X's within each of the fractions. So how many X's do we see with 1/4? 2. How many X's do we see with 1/2? 4. How many X's do we see with 3/4? Just 1. You only get to see 1. So which of these is the largest value? 2, 4, or 1? It's going to be 4. So most students walk 1/2. They don't walk 4. That's how many students walk a half a mile. So most students walk 1/2 mile. Okay. Any questions with that example problem? No? Weird. No questions. That was a joke. You can laugh. All right, question number 3. Oh, why did I erase my I did it again. All right, 1/4, 1/2, 3/4. Okay. So how many students, question number 3, how many more students walk 1/2 mile in 1/4 mile? So we said 4 students walk 1/2 mile, and then 2 students walk 1/4 mile. So how many more students walk 1/2 mile than a fourth? So to figure that out, you just subtract your x's. So 4x's minus 2x's, or 4 minus 2, equals 2. So 2 students. Okay. Question 4. What is the difference between the longest distance and the shortest distance that students walk? So the longest distance that they walk, we know, is 3/4. The shortest distance is 1/4. To find the difference, we would subtract the two. 3/4 minus 1/4. Okay, denominators are the same, so the denominator of my answer is also 4. Now I just need to subtract my numerators. 3 minus 1 is 2. So the difference between the longest distance and the shortest distance that students walk is 2/4 mile. Oh boy. Okay. Next question. What if a new student joins Miss Lee's class who walks 3/4 mile to school? How would that line plot change? So we have a new student, boys and girls, a new student in Miss Lee's class. This student walks 3/4 miles to school. So how would I change that in my line plot? It's quite simple. Do not overthink it. We know that that student walks 3/4, so I'm just going to put 1 more x above the 3/4. Okay? How would the line plot change? Okay? An x would go above the 3/4. Okay? Simple as that. Simple as that. That page is done. That page is done. Okay, turn the page to 667. The Sharon Show. Okay, so this question we're going to do together. Okay, 1, 2, and 3 we're going to do together. And then you guys are going to do 4 on your own. And then we'll go over 4. Okay, let's do this. A food critic collected data on the length of time customers waited for their food. Order the data from least to greatest. Make a tally table and a line plot to show the data. All right, so we have the data over here. Okay, we got a couple of fractions here. We got 1/4, I see, a 1/2, a 3/4, 1/2, and a 1/2. Okay, so that's 4 separate types of data there. And the smallest fraction I see is 1/4. Okay. Then we have 2/4, 3/4, and then a whole. So let's throw in some tally marks in each of these categories. So, all right, first 1/2. Let me change the 2/4 to a 1/2. 2/4 and 1/2 are equivalent, they're the same. But just for simplicity reasons, 1/2 here. 1/2, throw an X. 1/4, throw an X. Cross it out. 3/4, throw an X, cross it out. 1/4 X, cross it out. 1/4 X, cross it out. 1/2 X, cross it out, and then 1/2. These poor saps waited for their food for an hour. They're not coming back. Okay, so let's look at my line plot over here. Let's label these. We have 1/4, 1/2, 3/4, and then we can do 4/4 or a whole. Let's just do both. Or 1/2. All right, so let's throw our x's up on our line plot. So we have 3 above the 1/4. We have 2 above the 1/2. 1 above the 3/4. And 1 above the 1/2 or 4/4. Okay, so let's answer these 2 questions. Question number 2. On how many customers did the food critic collect? So they collected, this is don't overthink this, okay? Just count your X's. How many customers did the Food Critic collect data on? So it's the same number. How many X's do you see? Because those X's represent the customers that the Food Critic collected data. So let's count our X's. We have 3 and the 1/4. We have 2, 1, and 1. So let's find the total. We have 1 plus 1 plus 2. So 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7. So the Food Critic collected data on 7 customers. All right, question 3. What is the difference between the longest time and the shortest time that customers waited? The longest time was 1 hour. The shortest time was 1/4. Okay, so if I would subtract 1/4 from 1 whole, let me represent that in a picture. Okay, I have 1 whole here. Okay, and I am subtracting 1/4. So I have all 4 shaded in and represent a 4, 4, 4, so it equals 1 whole. And I'm taking a 4th away. See you later, 1/4. How many shades do I have left? 3/4. Okay, so the difference between 1 minus 1/4 is 3/4. Any questions on this problem? No? Okay. All right. Very good. All right, the next problem, this is where you are going to pause the video and try it on your own. Okay, I'll read you the problem. Then you will pause the video and complete the problem on your own. When you're done, you can click play again to listen to the problem. Okay. The data show the lengths of the ribbons Maya used to wrap packages. Make a tally table and a line plot to show the data. Okay, pause the video. Did you pause the video? Are you sure you paused the video? Okay, back to the question. You should have completed the question on your own. All right, first, let's use the data table right here. Transfer that information to our tally table. So let's look at all of our fractions. I see a 1/6, 2/6, 3/6. There are no 4/6, 5/6, and 6/6. So let's throw in our fractions here with tally marks. So 1/6, okay, throw an X, cross it out. 2/6, X, cross it out. 5/6, X, cross it out. 3/6, X, cross it out. 2/6, throw an X and cross it out. 6/6, X, cross it out. 3/6, X, cross it out. 2/6, X, cross it out. Now I need to put this information in my line plot. So 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. All right, so let's transfer our X's over here to our line plot. There's 1 X above the 1/6, 3 X's in the 2/6. 1, 2, erase that. 3 X's above the 2/6, 2 X's above the 3/6, 1 X. Oh, Mr. Perry, there is no 4/6. They just throw that in there to make sure everything's in order. Got an X above the 5/6 and an X above the 6/6. Okay, question number 5. What is the difference in length between the longest ribbon and the shortest ribbon? So the longest ribbon that Maya used was 6/6. The shortest ribbon that Maya used was 1/6. Since it's asking to find the difference, we are going to subtract. Denominators are the same, so the denominator stays the same in my answer. Now I just need to subtract my numerators. 6 minus 1 is 5. 5, 6 yard. Okay, this is where the lesson's going to stop for the day. Hopefully, I explained this well enough that you're confident to complete the reteach page. But if not, don't worry. Please join the Zoom session with either Mr. Pagu or myself, and we can help you out again with some further explanations. Okay, don't stress about this. If you understand, no big deal. Okay, we're here to help. All right, see you guys later.